So
Okay.
good evening, everyone. My name is Leonora Utubwati. I'm Director of Professional Practice at the Ghana Institution of Engineering. This evening, we have a webinar kindly hosted by Anyway Solutions on data acquisition and value-added approaches to managing pavement assets. So we're really looking forward to hearing the insights and, having a rich discussion after the presentation. So please go ahead. Thank you so much.
Thank you. Good evening, good afternoon, everyone. It's evening here in Israel. I am in Israel and I'm the CEO of Anyway Solutions. Hopefully you will find this webinar interesting. We've been around for quite a while, over 25 years now, working in many parts of the world. And we've evolved as a company to become a consulting firm that focuses on climate resiliency, and everything that we do is under the umbrella of climate resiliency. I know it has become a buzzword, but 25 years ago when we only started, it was already part of our, I would say, genes. It's the character of the company. We've been providing services of all phases of transport infrastructure projects, right from planning through to design, different types of designs, construction, supervision, quality control, stabilization solutions. Recently we are developing also asset management solutions. And this will be part of the webinar, the main part of the webinar that I will talk. We're part of a much larger group from Canada that was established in 1946. So there is history here and experience, quite a lot of expertise. We're a multinational company with people from different countries. Some of you may know us in Ghana, specifically through the lens of stabilization, but the services and the things that we deal with are far beyond that. Our approach to climate resiliency is a bit different than many other companies in the world, or the way that they talk about it. We understand climate resiliency to be much beyond only engineering. And we place a lot of emphasis on data collection as the world is changing. Climate is changing. I will talk about it in a few minutes. Climate is changing. And so the need for updated data is critical to take educated decisions, and the right decisions based on data that is relevant to the current change or the current climate. And climate is changing all the time. We're combining, through our approach, we're combining advanced technologies with a foot on the ground, with a presence and experience of being on the ground, which is very unique and important, because many companies you will find talk about satellites and the stars and sophisticated technologies, but they do not have foot on the ground. And this is unique about Anyway. And we see that as critical in order to achieve resiliency. Everything that we do is focused on enhancing climate resiliency of transport infrastructure projects. We also believe that localizing the solution is important, involving local communities. Some of you may recognize themselves in this photo, which was a training that we did in Ghana, revolving around rehabilitation and upgrading of roads through stabilization. And so enhancing the knowledge, relying on local understanding, local professionals, but also involving the communities in the processes of developing solutions and understanding what would be fit for purpose, what would work better for the project that we are either designing or supervising. or even constructing. We're not contractors, but we are involved a lot in the construction phases in many projects around the world. And I think that what matters the most is the fact that beyond the technologies that we bring and everything is the results. And for those of you who actually know us from the very small project that we did already in Ghana, or maybe a few projects, the result matters. And we're proud of being known to actually deliver good results of everything that we do. So a quick review of everything that we will talk about. We'll talk about the importance of climate resiliency and the lens. We'll touch a bit on the climate change in Ghana specifically. What do we expect from the climate change? What are the impact? What is the impact of climate change on asset management and other aspects of road development, of transport infrastructure? I'll talk about the technology or the use of technology in pavement asset management, data collection and analysis method. What is the future? Where are we going with these technologies? And I'll share some of the findings that we have, maybe conclusions of projects that we've already been involved in other parts of the world, in other countries. Unfortunately, not yet in Ghana, but maybe in the future, something will change. I'll talk about the challenges and you will understand. So why is climate resiliency so important? We can see that the climate is changing and we get extreme rains all of a sudden. I don't have to tell you about what is going on in Ghana over the past years with the floods and unexpected rains and collapse of water management and drainage systems. On the other side, we get extreme heats, we get droughts. In places that are next to the sea, we get sea level rise. So all of these changes that are becoming less predictable, they are more frequent because maybe in past years we would say, yeah, from time to time we have a flood, from time to time we have extreme rain. This is not the situation anymore. Extreme rains and flooding and unexpected short dramatic climatic events are something that we experience on maybe a weekly basis, some countries all the time. So Ghana is no different than many other countries in that part of the world, in that belt of the world. And so all of these actually influence transport infrastructure, the roads, the railways, everything, starting from rural roads, ending at highways. And the fact that the effects of these climatic events and climate change on transportation infrastructure is so detrimental is undoubtful. And so you get to see sectors that are critical for a country: agriculture, water supply, energy, telecommunication. And the consequences are that, people cannot go anywhere. People cannot get food, even food supply, even local food supply is hampered by that. Public services, the accessibility to education or to health services. So on one hand, on the left-hand side or the right-hand side, I don't know how do you look at it, but the left-hand side, if you look at the screen, the left-hand side, you have changes in weather, in climate. The other side of the screen is money. And this is what climate resiliency is all about. It's all about money. It's all about being ready for the climate change in order to save money in the future and save money even now. So let's briefly talk about climate change in Ghana. If you compare the trend of temperature in Ghana, if you just compare it to an average between 1971 and 2000, and then you compare what is going on today. Are we not saying that it is hotter now in Ghana than it was when we were kids? Yes, we do. Because it is true. You can see that it is becoming hotter and hotter. And that means that climate is changing in Ghana, and that brings more and unpredictable rain events, sometimes storms. With that, and with all the infrastructure that was designed 50 years ago, maybe 30 years ago, even 10 years ago in Ghana, you get flooding everywhere. All you need is a little bit of rain for 1 hour. Bang. Accra is underwater. I don't have to tell you about it. This is a fact. And so climate is changing in terms of temperature. But also, like there is a global index. The Notre Dame Global Adaptation Index actually rates countries all over the world. Actually, Ghana, this is 2013. Ghana, we are now 2025. Ghana has gone down from about 48 to 43 point something, which is not good. Norway or Denmark are 70 something. So we can see that the country is less ready for climate change, and we can all feel it. And that's why asset management is so important. Asset management is extremely important, and I will continue the webinar and you will understand why. What do we expect from climate change? As we all know, more extreme weather events with less predictability. All of a sudden, rain for 24 hours. It happens. And then it brings flooding. All of a sudden, no rain for a long period of time. Droughts. After droughts, when the soil is so dry, you don't need a lot of rain to create another flood. And so intense rainfalls and flooding are a result of that and can influence every aspect of our life. Of course, geological events, and I'm not talking about small landslides, massive, massive geological events. Maybe Ghana has not experienced that yet, but landslides are part of everything that is happening. Fires in the woods, landslides, as I mentioned, due to a dramatic event of water that all of a sudden just chops down or assist a part of the mountain to just slide down onto the road. Hopefully, no casualties in this case. And of course, sea level rise, which is relevant to Ghana, very relevant to Ghana, and it is the future. This is what is going to happen. So how relevant is this to the roads? What are the challenges? And so if we have weak soils, subgrades, under traffic loads, all of a sudden they fail much faster than they used to be. And then even granular and base course under construction traffic loading, they also fail. And premature failures of pavement shortly after construction, all these difficulties and all these issues, challenges of road construction are becoming more and more relevant with the climate change. Think about the drainage and all the drainage elements that were designed in roads that were built long time ago. They're not relevant anymore. They cannot cope with the changes of climate or the effects that climate change is bringing. So, climate change actually requires better pavement asset management. And when we think about what is actually pavement asset management, I know that most of us will, will think about, it's not really important. Well, unfortunately, many countries like Ghana invest a lot in design and construction. While pavement management is the process of planning, maintenance, and repair over, a period of time to actually maximize the lifespan of these assets. When we talk about asset management, when you say asset, you mean something that I care about. When you say management, it means that you will invest in taking care of them. Unfortunately, in many countries, Ghana is not excluded. Governments actually invest more in design and construction of projects, new projects, and less in rehabilitation. Although now, in recent years, now we see two main highways in Ghana that are being rehabilitated by the same contractor, by the way. But anyhow, so there is some awareness, but again, maybe we could have avoided the reconstruction of a highway if we actually took care of it through its lifespan. But I mean, this is what we are going to talk about. It's like you grow your kid, you kick it out to the street, and you tell them, go and live your life and manage yourself by yourself. So, I mean, there are different pavement deterioration, there are different aspects of that. So over time, every pavement degrades. Every pavement, it doesn't really matter. So over its lifespan, there is deterioration of the road's condition. Pavement deterioration is usually measured through various distresses and different indicators, like IRI, like roughness index, which is an indication of the condition of the road. Rutting, cracking, surface silt degradation. All of these are signs of the condition of the pavement and the asset that we invested in so much. And if we don't manage that asset, then we do not see these deteriorations at the right time. The consequences are only more expensive, not more than that, more expensive. More expensive, and until you get to actually deal with that, many people actually suffer, and we all know about it. Now, these are, pavement performance of how do you actually manage pavement through the lifespan, and every time you kind of interfere, you extend the pavement lifespan to be the design one. You cannot expect that, you design a road for 20 years, without doing nothing, that road will not last 20 years. So you have to interfere, you have to actually take care of that asset so that it will eventually reach its lifespan. And this is what asset management is all about. But you have to know, you have to look after it. And I'll show you some really cool technologies and techniques to do that can allow a country to manage its assets in an amazing way and actually know where to do, where to actually invest. So there are, pavement investigation processes. They can be cumbersome, and they depend on asking questions along the way, whether this happened or that happened, and it can be a cumbersome process. You all know, probably, well, not all of you, but some of you may know this type of forms. You send a team on site, and you start measuring and recording. This is all dependent on how a person is looking at it and what are the interpretation of a specific person that has done that review of a road. So, I mean, you can walk the road, document observations, and maybe sample materials, you use a checklist or a guide, you take photographs. Sometimes you do dynamic cone penetration, DCPs, you check the thickness. These are all long processes, takes time, requires you sometimes to close the road. And by the time you will finish the investigation, this is, by the way, Sefi Galgut. He was our country manager not too long ago. Some of you may know him. I mean, the road is in a different condition altogether. So you can walk the road, you can look at the problems, you can look at the, what are the causes of these stresses, etc., etc. What we offer in our system, in our approach, is not getting away with all of this, but getting to a stage where your decision to actually do these actions are optimized. You can better decide where do you want to walk the road, where do you want to actually look closer to what are the problems, what is the cause of distress, what is the condition of the drainage if it has existed at all, what are the safety elements, aspects of that section of a road, etc., etc. And the system that we offer will allow us as engineers to better deploy our efforts. So some of the stresses, the damages that we all know as engineers that happens, but if they are there and no one is recording it and quickly take a decision to take action, maybe there is no need to take an action, but if there is and no one is taking that action, then roads actually becomes like this on the left-hand side. And there are different distresses. I don't have to go into the details of that. In everything that we do, for those of you who knows us, we bring technology. We bring technology in, wait 1 second. We bring technology in a way that it will allow us to quickly collect data and quickly analyze the data and then decide where do we want to put our foot on the ground. And that's the key issue here. That's the key aspect of what we are talking about. Why data collection is so important. So the advantages of data collection and not sending a team to fill up forms and close the road and put it in a folder, and that folder goes into a drawer somewhere and no one actually looks at it. It's faster. It's much more efficient. It's a holistic analysis of the complete road. You will understand in a few minutes when I talk about it. It integrates different data systems, facilitating access and collaboration among stakeholders because you provide accessibility to the system to different departments on the same software, on the same platform. And it reduces information silos. Do we not all know that the Department of Maintenance will not talk to the Department of Design, that will not talk to the Department of Planning? We all know of that. And sometimes there is information in these silos. People do not talk about these things. And so if you create an automated data collection system that sits on a platform that is accessible to different departments without the need to, take yourself somewhere and show someone something. They just click on their keyboard and get access to a system that shows them the state of the roads and manage better the assets. So just a quick comparison of traditional pavement distress surveys, like sending a team to the site. And we all appreciate and understand that employment is important. And we're not saying that the people who does that will be unemployed. On the contrary, they will be able to actually do other parts of the asset management process and actually contribute better to managing better these assets. And so instead of sending people to the site, visual survey, and labor intensive and slow, etc., you use a digital data capturing, optimization of artificial intelligence, another buzzword of today, analysis and modeling. You will see you process it faster. Like within a few weeks, you can analyze hundreds of kilometers in a few weeks and get accurate, real data that actually will allow you or the owner of the assets to better decide where do we want to invest our efforts and where do we want to maybe dig further. Why is this section so deteriorated? What's the problem? Let's go there instead of just go through 124 kilometers of a road and realize that there is only 20 kilometers that are problematic. Just know that faster. And this is what we're talking about. This is why data collection is so important. And what are the data collection methods? And there are quite a few. They're all very much advanced. So, like everything in the world, we can use cell phones. We can use GoPros, other camera systems, drones, satellites, LiDAR system, more advanced. This is actually a car-mounted LiDAR system that we have, that we ran in a project that all we did is actually designing the rehabilitation of the project. But before that, we had to know exactly what is going on. And so the client has asked us to bring in a LiDAR-based system. And instead of bringing an airplane, we have a LiDAR system that sits on the car and just collects the data to the millimeter. So as you can see, there are different levels and types of data collection, but they are all digitized, and they will all go onto a platform, GIS-based platform, that will be accessible to all stakeholders. So automated pavement distress investigation, I mean, it starts with your cell phone sometimes. It is all GIS-based, and if you can see the different colors here, they are indication of the roughness index of different parts of the road. So if it is good, you don't have to go to that road. But if it is bad, you may want to decide, I'll go and investigate there, instead of just waiting for my team to walk that road through 3-4 months time and give me these packs of papers that who knows how we will know where everything is and where are the photographs. And so it starts with the roughness index. It's on the phone today. You can run the car, or the system just gives you where is the problem. And by only that, only IRI, you can decide where do you want to deploy your teams in order to investigate better that road. So already you're saving time. Already you're getting data in a much faster way and much more accurate. No person that will walk that road will tell you what is the IRI of that road. No person. You'll have to run it again with another whatever. So if you combine these systems together into a one system, okay, you can use a a LiDAR, a drone-mounted LiDAR system, which is very sophisticated, but it doesn't really matter which system you will use. It will all be digitized, and it will all be quickly accessible. Quickly will give the results, and quickly the data will be analyzed and available for the decision makers. And again, I'm coming back to climate resiliency. Time is of the essence. Time and collecting data quickly and getting to decision where to go is critical, because climate is changing quickly, and that road that you will not treat today, or you will not deal with the problems of that road today, will only get into a worse condition, and the investment to rehabilitate and upgrade that road will only be more expensive. And then you have the portal, a magic. You run hundreds of kilometers with a system. You get GIS tagged photographs of every spot, as you can see here on the screen. You know exactly where you are. You know what is the problem. You understand the system can analyze and tell you what is the specific problem at a specific point. You don't have to send anyone. You just draw that road with a system that collects that data. And you have everything on your computer. You don't have to go anywhere. And we're talking about hundreds of kilometers within weeks. No other system. And it's critical for asset owners. And it's critical for contractors, and it's critical for engineers to understand that these technologies are there, out there, available and accessible and not expensive. And data collection is critical in order to enhance the climate resiliency of transport infrastructure. And that's why we are here today. How do you analyze? So you define the project area and you capture the data. Easy. You process the data and you create a digital client portal. You can add in supplementary data, like if we have a system that goes on the road and takes the whole lanes of the road and the drainage, etc. Because it is GIS based, you can patch on top of it an analysis of catchment areas through satellite, also GIS based. And all of a sudden, that road, and with the data collection that is digitized, you get a much clearer understanding of what could be the problems of that section or the complete road. And then you analyze the data quickly through AI, take a decision. Where do I want to go? Where do I want to further investigate? You provide insights. You issue a report. All of this is days. Days. Not weeks and not months. Days. And this is where the world is today with regard to asset management and why it is so important. So you define the area, whether it is a polygon or whatever. You just, whether it is one road or a network of roads, doesn't really matter. You determine which technology do you want to use, and you just implement it. Here you see a few samples, okay? As I told you, this is a LiDAR, a car-mounted LiDAR, a multispectral camera that scans the road, and as you can see, provides immediately AI analysis. Forward cameras that are attached to the front part of the road of the car and takes photographs every few meters. and AI analysis of that road, or IRI analysis through your cell phone that is only attached to the windshield. You can see also back-looking systems, although we do not recommend. We less recommend back-looking systems. I will talk about it. Or as you can see here, this is a system that we've used many times, and it's kind of a system that takes IRI, take photos, and the data is all GIS based and is analyzed through AI, and within days you get the results. And this is how it looks like. This is how it may look like if we're analyzing a rural road somewhere. You get a photograph, the whole road, where you are on the road, what is the location, and the information about the condition of that section. You can, some of the softwares create digital twins. You get to see, and the artificial intelligence software analyzes each and every crack or deformation in the road. And so the data is readily available and can be categorized according to whatever the country or the state decides or defines. And it is an incredible tool, incredible tool, nothing less than that. And then you do the field work. I mean, this will optimize the on-ground efforts that you will invest eventually when you want to, eventually you need to go there. Eventually you need to go and see why there is a problem. The system will tell you, here is your problem. These are the problematic sections of your road network. Then you have to decide where do you want to go. And this is why I said that there is no unemployment here. People will just do different things and different aspects of the process in order to improve the results and enhance the resiliency of the assets that we're managing. So eventually, and also there, you can use ground penetration radars and all other types of sophisticated elements, along with DCPs and coring and testing, etc. This is actually an investigation that we did on a rigid pavement in a country, so that has failed. But there are challenges. There are challenges. I'm not saying that there are no challenges. There are challenges. So some of the challenges are related to the obvious conditions. We all know how crowded the roads are, which can be an issue. Although you can drive slowly, but you can pick hours of, when you drive. We all know that the weather condition can actually be a bit difficult. There is the cultural and institutional resistance. And we've seen that in a few countries, although recently we're now seeing that younger engineers in institutional authorities are more open to advanced solutions. And so it's a challenge, but we're hoping that that is something that will get better. There is a limited cybersecurity, but really it's not critical. Really, most of the platforms are well secured, and really, eventually, what kind of data can be taken from them? And there is social aspects. Sometimes communities, they start asking questions. Why are you driving here? Why are you taking photographs? What is this system? What is going on? And also there is the risk of theft. That's why when we talked about forward-looking or backward-looking, then we would like to recommend forward-looking, because you can see your system at all times when you're in the car. the risk of theft is a bit limited. And also, there is the connectivity issues. Sometimes in remote areas, there is not sufficient connectivity, but we get over that by collecting data and then uploading the data at once. In some places of the world, we can use satellite-based internet connection if it is extremely important to online upload data. Sometimes there is lack of digitized, structured, and high-quality data that actually makes the AI model a bit difficult. We've seen that over the past even few months that has become much better, and we're now analyzing only based on AI, and the results are about 95% accurate. There are obviously cost constraints because clients do not like to pay before they see something, but I mean, it's a given. Sometimes there is upfront payments that are required. Not all clients like that. And sometimes there is just the lack of expertise, of capacity. But we take that into consideration, and building the capacity is part of enhancing climate resiliency, and so it comes with a package. There are ways to overcome these challenges, and they're not, it's not very difficult to do. The technology is moving fast forward, really fast forward. What we are doing today was not possible only a few months ago. Only a few months ago, we had to deploy engineers to verify the AI. It's not necessary anymore. And the systems, they move fast forward, really. Sometimes I say that there will be a time where we will take our cell phone, we throw it into the air, and it will just be a satellite. And will give us data about everything that we want. And so the data analytics really is supporting good engineering, and it actually gets the decision makers to take better decisions. Satellite technologies is moving at the speed of light. The things that we get from satellites today is unbelievable. And so it's becoming more and more available that, in the near future, we may be doing asset management based on satellites. In some places it is done, but the conditions has to be such that the satellite will clearly see that road, and it's not the case in many parts of the countries. And so new data sources are also coming, especially in countries where there are sophisticated cars that comes into the market, and every car becomes a source of information. How many times they actually use their wipers in order to clear the rain. How did the car move on a road, and as an indication of the roughness of that road? I mean, the future is like the world now knows every time that we go to a shop and buy something, then asset management will in the future be based on only the cars that drive the road. You won't have to do anything. The cars will give you the information that you're looking for. So this is the future. And our findings from projects that we were already involved in most countries, the majority of the roads are unpaved. And the conditions of these roads, well, they range from very poor to poor. We all know that. And in many countries, there is zero data. Although they will tell you that there is data collection, we send the teams and they collect the data, and we have that stored in a folder. Eventually, there is zero data that is used to take smart decisions. No one actually looks at the system as a whole. Data acquisition must be coupled with interpretation. And this is where AI comes in. The interpretation of the results is critical. And this is moving fast. Portability is a key. It needs to be simple. It needs to be, we need to be able to mount a system on each and every car. If we have a police force that is going around an area all the time, you put the system on their car. They will collect the data for you on a daily basis. You don't have to do that. It's possible. Or trash collecting trucks, whatever. The barriers, the batteries of a system needs to go on planes. It's critical, and that's already the norm. Keep it simple. Keep it simple. We learned when we started, systems were a bit more sophisticated. They were not as simple as they are now, and they're becoming more and more simple. So keep it simple, and that is something that is important, because if you keep it simple, people will use it. If you bring it to a new territory, to a new system, to a new authority, to a new region, if it's not simple, it will just be on the shelf. People will not use it. And obviously, try and work with local professional companies that will eventually enhance their capacity, and they will become those who make it happen in a specific country or territory. So in conclusion, pavement asset management is extremely critical for each and every country in order to enhance the climate resiliency of road network. Many of the roads were built before climate change started to be as effective as it is. And the technological advancement in data collection, they will allow us to collect data quickly, analyze it quickly, and get a decision quickly. Some places, I'm just reminding, cold in-place recycling. And that was the ticket that we came with into Ghana a few years ago. This is the continuation. I don't want to talk about that because we're talking about data collection. So there are many more technologies and techniques that can come into play once you actually know where do you want to invest your efforts. It's all about optimization. I have a budget of $1 million. This is how my network looks like. These are the bad parts, the good parts. Where do I invest in order to optimize the money that I have? Or how much money do I need in order to get from very poor to poor, or from poor to, I don't know, to better? And using advanced data collection systems actually allows us to do that. So thank you very much for listening. This is my email. Don't be shy to send me questions if I've not been able to answer questions here. And if you want to learn more about Anyway and our approach, you can scan that. I don't know if we're sharing later the presentation. I'm more than willing to do that.
Yes, please. That would be great.
Mm-hmm.
So I'm open to questions. I think we have at least 10 more minutes. Please go ahead. Questions.
Sure. Thank you so much, Zivik. We've been really, really enlightened. I think it's actually a very timely
Ladies, guys, don't be shy. Kofi, I can see that you have a question, please.
Yes, please go ahead.
Charles.
Prof. Adams, please go ahead.
Yes. Good evening. Thank you very much for such a insightful presentation. I just have a little question for you. You were talking about asset management, but you know that asset management demands a whole organizational framework to align with the decision making and the finance, the systems, everything. Already, most low and middle income countries cannot even maintain their networks, let alone talk about asset preservation, which asset management really focuses on. So from your observation and experience, what do you think some of these countries?
Great question, because
but you are talking about preservation or asset management.
No, sure. In most countries, Charles, it's preservation. In most countries, because most of the road networks have been built before already, like, I don't know, 50, 60, 70 years ago, 40. They're all there. And it's a great question. In many countries, they are not even in the phase of understanding the network. They don't have a picture of the network. So what we are suggesting to a country is, first of all, understand your condition. Very quickly deploy such a system. First of all, get the data. Understand your own network. Think about the greater Accra area. And within, let's say, 1 month, I will give you on your computer a system, GIS based, and you can click and go to each and every square meter of whatever road that you want. And then take a decision. But I agree with you, Charles, if eventually the decision will not be practical, will not be based on we need to do something, these types of systems allow you to take that decision more cleverly. Know exactly where do you want to go, why do you want to go there, have a closer look, and optimize the investment. But I agree with you, there is a need to have maintenance teams. But a country in other places, what we have seen, they do two things. One of them, they give a section of the road to a community, and they pay the community to actually preserve, maintain. And we all know that there are three things that will kill your road: water, water, and water. So only keeping the drainage open will actually preserve the road better. So this is one. Countries that do that, and we've implemented such programs in other countries. Another thing is that the country actually outsource the maintenance to contractors that are then measured by the quality of that road after some time. And why is it possible? Because, Charles, I can look at the road today, they start maintaining it, and I can come in a month's time, in 5 minutes, I get the data, and I know whether they did good work or not. And then I can either pay them or not pay them or whatever, decide what I want to do. So these data collection tools, they go in different directions, but the best thing is that it is optimizing where do you want to actually invest your efforts. I hope that I answered your question.
Yes, thank you very much. Yes, thank you very much. Thank you for your response.
You're welcome. Please, there was another question from someone. Someone raised their hand. Thomas, Anna, Mahama? No one. Nicholas?
While we're waiting for questions, I think I just want to encourage everybody to please fill the attendance sheets. We've posted a link in the chat, so please just fill in your name and your details to record your attendance. Thank you.
Important.
Well, if there's no question, maybe I can ask a follow-up question.
Yeah, please go ahead.
All right, thank you very much. So because of what you just said, that the maintenance is crucial and ought to be done. Some people think that, well, then we should go for performance-based contracting, where you design and then you maintain. But you know that when you do that, it calls for a long-term commitment to maintenance, which, if it was done properly,
I cannot hear Charles. Sorry, he's being cut off. Is it only me or?
Yes,
in the
Prof. Adam,
network.
okay.
Hello?
Yeah, Charles,
Yeah,
please
now we
repeat.
can hear.
So I'm just asking for what your comment will be on performance-based maintenance contracts, because of sometimes the cash flow issues that governments have, and vis-a-vis, not being able to commit to paying on time, and therefore maybe if you sign a long-term contract, then if you don't pay, you still don't get the result. What will be your comment on that?
We have seen in many countries that these type of contracts do not actually work. They do not achieve the goal that someone actually thought about it. The contractor, whether he was paid or not, and if he's not paid, he's doing nothing. And if he's doing something, it's probably the minimum possible. And it is for a short and limited period of time. Think about a road, Charles. You design a road for 20 years, and these types of contracts, they will, the contractor will take an obligation to maintain the road for 3 years.
Mm-hmm.
Correct?
Yes.
What happened after these 3 years? Who takes charge of that road? Who knows what is going on with that? So it's like I said, there is a misconception with governments. Let's build new projects. Let's invest a lot of money in design and construction. They don't pay on time ever. It doesn't really matter whether it is the Ghana government or the Swiss government. Okay, maybe in Switzerland they pay on time, but in many other countries, no government pays on time. Don't kid yourself. But eventually, you get an asset that after 3 years, let's say that it was a fantastic contractor and they took care of that road for 3 years. What happened then? Who knows what that road is like after 5 years? Who actually looks at that road? What we are talking about, the critical issue that we're talking about here in this webinar, is the ease of data collection for the government to take a clever decision. And this is important because if you don't get that data quickly, if you do not analyze that data quickly, and it is not expensive, Charles, it's not expensive at all, then that road after 3 years, let's say that that contractor was paid on time and they did everything. After 5 years, what? Who knows what? No one. And so it's critical for the asset owner, which is many times the government. What we are now trying to do is to bring a second tier type of ownership, let's call it like that. We're developing now a tool that will not be for the government, but will be for local governmental authorities, because they actually have to take care of these roads. And so we're trying to build that up. And so localize the solution. Those who actually care about the assets should take care of them. Governments, they don't care about their assets. They don't care. They don't care about the assets. It's a given. And you know what, Charles, I don't know when you were in the United States of America, probably the worst roads you will see ever. Okay, maybe not the worst, but really, really bad. And it's, this is the United States of America. Their roads are in terrible, terrible condition. They're moving from asphalt back to gravel. So I'm saying that data collection, digitized data collection, and artificial intelligence and advanced tools must be in the hands of every local authority or federal authority if they want to actually manage their assets. And most of their assets are already there. They have been there before you were born.
Yeah.
It is.
Yeah.
If you have an asset, you have to manage it.
Yeah, true. You're right.
Yeah.
You're right, but I don't know what kind of costs your systems, how much your systems cost. But we have already acknowledged that most governments don't have. They say they don't have the money. I cannot say they don't have the money, but they say they don't have the money. And we know that technology is getting cheaper. However, our experience also shows that, cloud-based systems, the license, the technical support run into hundreds of thousands of USD, even for low and middle income countries. And most countries don't have, may not have the money just to pay for the system before they can also send their teams to go and collect the data or whatever. And these days, the tendency for companies may want to collect the data for you, which is even more expensive. I don't know how you are localizing this to allow the cost to go down.
As I said, you use local stakeholders. Okay, in the beginning, you have to do some capacity building, but eventually the client, through their own whatever resources, will just collect the data. Think about in Accra, okay, or in Kumasi.
Okay.
Which type of municipal cars goes on the street every day? Every day, on each road.
Mm-hmm. Well,
Put the
waste management
system,
vehicles are going around.
put that system on these cars. Finish.
Mm-hmm.
It's not expensive.
Okay.
So it's only about prioritizing. If the
Okay.
government wants to actually take care of the assets, they need to know that they have to invest in that.
Mm-hmm.
And it's not a big investment, Charles. We're not talking about
Well, it's not,
millions
but
of dollars.
they say they don't have money, but it's not a big money. I agree with you.
It's not. I see Engineer Mahama he wants to ask. It's not about money, Charles. You know what? Someone told me once. It's never a money problem. It's only a priority problem.
True. I agree.
Yes, Engineer Mahama, please.
Well, good evening.
Good evening.
And thank you for the, let me say, the education, or let me say, refresher courses that are coming with a lot of AI. I didn't join from the onset. You know, today Blaster was playing, so we're also enjoying partially our football team, so we came here a bit late. But granted, the data you are speaking about, is it relative to like under traffic count? And secondly, with regards to pavement structures, as well as a concept like the falling weight deflator text related. I just want to get that one before maybe I can make some submissions, if you got me right well.
So you ask what type of data would the system collect?
Yes.
So the system will collect each and every deformation type that you know of the roads that will be scanned by the system, and artificial intelligence will analyze, detect, mark, show you exactly where it is, and will actually even rate the severity of it. This is how detailed it is, and this is by driving that road only once. Finish. That's what you need today.
Okay, so it's like let's say if you've identified a distress on a section of your road, and so you move in with any of the type of machines you spoke about, and so with the artificial intelligence coming in to do, like, maybe I would have wanted to do my physical coring to run my various tests to understand what actually happened within that area, whether it's dampness, whether it was overload and other things. This data IT will be able to come out with the same report or very close to perfection, right?
Yeah, no. But I want to take a step back, okay? Because
Right.
you're talking about a section of a road. We're talking
Right.
about look at your road network, see where
Right.
your problems are, and then unfortunately, Mahama, you have to go on site and understand what is the cause of the problem. But
Right.
if you just go wherever you want and go on a road and go 100 and some kilometers to identify a very specific section, and only then after 3 years you go and dig it out and see what the problem is, you'll get nowhere. But if you quickly have the data, and if you have a nice understanding of your road network, then you optimize those actions that you just talked about. Where do I
That's
want
right.
to go? And
That's
this is
right.
the whole story here.
Well,
Optimization.
right. Right. Okay. I think I
Leonora,
get it.
how
I
late
get
do
it.
you want us to stay?
Is that?
Another, some more questions? I saw someone wanted to ask something. No? Vivian, you wanted to ask something?
Hello.
Yes, please.
Yeah, good evening, sir. Yeah, I want to thank you so much for the submission and your education. I'm highly enthused and highly delighted about you opening our eyes over this data servicing and assessment concerning our project. But I want this to be clear to me. I think a project needs to be done before introducing this system to be able to figure out the the rigidity or the completeness of the project per specification. I am of a view that can this assessment together with the data technology be looked at from the beginning before the project starts, so that after the project, no one goes in order to maybe check the deformation that might rise up in the project. Is there any system? Thank you so much.
Thank you for a very, very bright question. What is your name? I only see Samsung SMA, and so.
My name is Michael.
Okay, Michael. A
Yeah.
very bright question, and the answer is yes. There are systems. We have a system like that that actually is managing projects where data is being collected by similar systems. And just imagine you have a contractor on site and he is supposed to put a 200 millimeter of base course. So let's say that the contractor actually brought a base course material. But instead of 200 millimeter, he puts only 120 millimeter. No one will actually know about it or notice, and it will take years before that road will deteriorate after 6 months. No one will understand. There are systems today that you run through the project while he is contracting, and you actually verify. You cannot verify the quality of materials, but you can verify the level. And you use a car-mounted LiDAR system that goes on that road, and after 30 seconds, that contractor will know, or you will know, if that contractor needs to go to jail or he needs to actually get his money on time. There are systems like that, yes.
All right, thank you so much. And I believe your system will support this preliminary event to be, assigned before a project is taken. Am I correct?
Yes, correct.
All right, thank you. Thank you so much.
You're welcome.
Zivik, there's one question in the chat box from
okay.
Ebenezer.
I don't see the chat box. Do I
Okay,
see?
I can read it out for you.
Oh, okay.
It says, please, can you mention some of the AI, I suppose, tools that can be used to analyze the data after collecting them with these technologies?
Okay, well, the AI tools are based on known engines. How the AI world works today. Okay, let's talk about ChatGPT. ChatGPT as an engine. You can use that engine. They will give it to you. And then you take that engine and you teach it something. So what we did, we took a Gemini engine. We taught the engine to identify specific distresses. It takes a lot of work and it takes a lot of effort. And eventually, you use off-the-shelf engines, but you teach them to do something specific. And by doing that, you are getting the results as accurate as you want. And the more projects we do, the higher the accuracy. But this is how it works today.
Thank you so much. I think it's a very, very timely presentation because our members are asking for more training and enlightenment on machine learning and AI in different engineering applications. So it's really, really, really key. So thank you so much.
I'm happy. We're happy to share. And hopefully someone within the ministry or the Ghana Highway Authority will take a decision to actually embrace such a technology and actually make a difference, really. It has to make a difference.
Thank you, Zivik. I know it's probably quite late in Israel right now. I don't know if you have if anybody has any last question they'd like to ask, and any last questions or comments or thoughts. But if not, I'd like to say on behalf of the Ghana Institution of Engineering that thank you so much for taking this time. I know it had to be rescheduled from a few months ago, but we thank you that you came back to us and you've given us such an enlightening webinar, and we look forward to further collaboration.
Thank you. We thank you for the opportunity, Leonora. Thank you so much.
We like to share. Thank you so much. Thank you. You have a good evening in Ghana. Thank you, guys.
Thank you. And God willing, we'll be able to share the slides as well. So
yes, I send them to you.
Thank you very much.
Thank you. God bless you. Thank you.
Yeah, so for those who've signed in as attendants, would use your details to be able to send the presentation round. So please, if you haven't already signed the attendance sheet, please do so. Thank you so much and have a good night. Bye-bye.
Thank you. Thank you. Good evening.
Thank you.